Closely related to the similarity between pointers and arrays is the topic called pointer arithmetic. Let me show you what I'm talking about. It is possible to add an integer and a pointer. In other words, if you had an integer x and a pointer p, you could simply say x plus p and get a valid result. You would actually get another address, and this is how it would work. Let's say you've got an array called array, and it's got 100 elements in it, and then you've got a pointer and you set it to point to the beginning of that array, and then you've got a second pointer. It is possible to do the following equal sign. You can say pointer 2 equals pointer 1 plus 5 plus 5. That's the arithmetic part. So let's think about that. Pointer 1 is an address. Let's say the address is exactly 1000. Let's just say, as an example, address is 1000. Pointer 1 is 1000. Now we add 5 to that. Do we get 1005? No, we don't. You might think that we would. We don't get 1005 and treat that as an address. And the reason is this. Pointer 1 is pointing to an integer, and an integer is 4 bytes long. So what this actual piece of code is saying is, don't move along 5 bytes, move along 5 integers and take the memory address of that piece of memory. So how big's an integer? Well, it's 4, and there's 5 of them, so we actually have to move along 5 times 4, which is 20. So ptr plus 5, if ptr is a pointer to an integer, equals 1020. If ptr1 just happened to be a pointer to a char, then ptr1 plus 5 would actually have an address of 1005. Now if ptr1 happened to point to a structure, and that structure was 100 bytes in size, then ptr1 plus 5 would actually be 1000 plus 500. Anyway, whatever address that you end up with is put back into pointer 2. The question is, how does that all convert back to the variable called array? Well, if you recall that ptr points to the very first address of the array, the very first element of the array. It's the address of the first element. So if the address of array was 1000, what would the address 1020 represent? Well, it would represent 5 integers further up the array. In other words, the 6th integer of the array. Not the first or the second or the third or the fourth or the fifth, but the 6th. In other words, in this example, ptr2 holds the address of the 6th element of the array, and ptr1 holds the address of the first element of the array. You can also think of that as ptr plus 0. Anyway, let's have a look at a bit of a summary of what we're trying to get at here. Now, remember that pointers and arrays can be almost interchanged, at least syntactically they can be interchanged. What we've got is this expression, ptr2 equals the address of the 6th element of ptr1, or it's the address of the 6th element of the array, whichever way you like to look at it. Now compare that line of code, or that expression if you like, with this. What I'm asserting is that those two expressions or statements are absolutely identical, and it doesn't matter if ptr1 is an array or if ptr1 is a pointer. This is what pointer arithmetic is. This is a bit of a revelation to people. I remember when I first learnt this, I just couldn't believe that it could possibly work. And then I went and I wrote a few experiments and compiled them, and they worked, and I just had to live with it because it does work. They are interchangeable, completely interchangeable. Here's another way that they're interchangeable. If x is a pointer or an array, it doesn't matter which, then these two expressions are interchangeable. Now we saw this before, we kind of saw this. X brackets 10. Now what do you think that is? That is the contents of the, if x is to be treated as an array, it's the contents of the 10th element of the array. Now that's probably a little unfortunate that there's only 10 things in the array, but never mind. That will actually be the 11th element of the array. And the second expression there, take x plus 10, if x is a pointer, then we're actually going to move 10 integers further up the memory space and take asterisk, we'll take the contents of that. Either way you do it, you get the contents of the 11th thing in the array, if you'd like to treat it as an array. Either way, you get exactly the same thing. Alternatively, you could write this. Now this isn't the same as the first two, but these are the same as each other as well. This x brackets 10, if you take ampersand of that, then obviously you're saying the address of the 10th element. What I'm going to assert to you is that x plus 10 is also the address of the 10th element. I suggest that you pause the movie here and just stare at that. Really convince yourself that you know what's going on here, because it's very, very confusing. I'll just give you a second or two to do that. Okay. Now we are going to have a look at some code examples of this, so don't panic just yet. Let's just see the golden rule first. The golden law of pointer arithmetic states that for any pointer or array x, x brackets 10 is exactly the same as the contents of round brackets x plus 10. See if you can write that down somewhere. It's really vitally important that you know that. You've got to be able to read other people's code when you see expressions like that and know what it means. Now in pointer arithmetic, just a couple of other things that you can do in pointer arithmetic is you can subtract an integer from a pointer. It's possible to do that. You'll still get another pointer, you'll get another address, and it works exactly the same way as addition. And it's also possible to find the integer difference between two pointers. So you can say pointer 1 minus pointer 2 equals something, and that something will be an integer. And it will not be, if pointer 1 is 1020 and pointer 2 is 1000, the difference between them is not 20. It's not. It depends on what they are pointers to. If they're pointers to chars, then it's 20. If they're pointers to integers, then it's 5. And if they're pointers to structures and those structures are 20 bytes in size, then the difference is 1. Interesting. Let's go and have a look at some examples of that. Here's arithmetic.c. It's just going to be a quick demonstration of pointer arithmetic. Let's say we've got an integer array that looks like that. It's got 10 elements in it. And then we've got a pointer that points to that array. Now, I'm going to read in a number from the keyboard. I'm going to ask the user which element they would like. And hopefully they'll give me an answer in the range 0 to 9. And then I will print out various expressions. I'll print out that expression. I'll print out that expression. I'll print out that expression. Same again using the pointer instead of the array. And again using the pointer instead of the array. And I should get the value of the array element that we're referring to, and then the address of that element is there, and that is exactly the same thing written in a different way. And all those, the first four should be exactly the same. Those four should all give us the same answer, and those two should give us the same answer, and then I'm going to do a bit of pointer subtraction here and find the difference between element number 9 and element number 1. Remember that integers are 4 bytes long. Okay, so let's have a look at that and run it. Which element would you like? Well, let's say element 3, 0, 1, 2, 3, so it'll be the fourth element. Each one of them is the number 4, and the address of the fourth element is the same no matter which way you describe it. Also, the pointer difference, the address difference between element 9 and element 1 is exactly 8. It's not 8 times 4, which is 32, it's 8. Okay, so I hope that proves my points. Okay, so that's pointer arithmetic. Let's move on.